This is a detailed final exam review for intermediate algebra. In your modules, you will have all these problems worked out, but I thought a video would also help. So I'm just going to go through. It's going to be a bit long, but I'm going to go through each of the problems and explain how to work them out to help you go over. You should really take the time first to do the review on your own without any of the answers in front of you. And then just kind of fast forward in the video to those that you're stuck on and want to see more detailed, see them worked out in more detail. All right, so our first problem, notice there's no variables. We have a simple order of operations. So don't forget, this is the please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division, whichever comes first, and then addition and subtraction, whichever comes first. So we're going to treat that radical as a parenthesis, of course, and work out what's inside of that. -1. Notice the negative is in parentheses, which means the negative is also being squared. It becomes 1 plus 24. And that, of course, is the square root of 25, which comes out to 5. So I'm just going to rewrite what I have. 5 plus 8 divided by -2. You need to do this piece first because multiplication and division always comes before addition. Most common mistake is to add the 5 to the 8, but you're actually adding 5 to -4. And of course, 5 and -4 gives us 1. For our exponents, when working with exponents, there really doesn't matter the order you work on it. You can actually work inside the parenthesis first to clean up what's inside before you raise it to the third power, or you can just raise everything to the third power and get rid of those parentheses. Either method is going to get you the same answer. If you're struggling with exponents, you can always try both and ensure you get the same answer. I'm going to go ahead and clean up what's inside first. So what that means for each problem, for the 3 to the -1, I'm going to move that up. So what I have now is I'm going to put the 3 up here. When I look at those A's, so take a look. I have A to the 5th minus -5. You know, my biggest recommendation is don't try to do everything in your head. Write it out off to the side as you're working it out, and you're less likely to make mistakes. Take the time to do that. That's 5 plus 5, so that's A to the 10th. And then for the B's, same thing. I have 2 minus -4 because when you have, remember the quotient rule, same base, subtract the exponents, and that's going to give me B to the 6. Notice neither of these are negative. If either had come out negative, that's when you would stick it in the denominator. We have nothing left in our denominator, so it's over 1, which means there is no denominator. When anything's over 1, we can just eliminate the denominator. So this is what I'm left with to the 3rd. This is power to a power rule. 3 technically has a power of 1. 1 times 3 is just 3 cubed. 10 times 3, 6 times 3. Please do not leave 3 cubed, and there's your 27A, 30B, 18. Moving on. Scientific notation. Just remember, when you put something in scientific notation, you want the decimal to be after the first non-zero number. So how many places to get there? 1, 2, 3. So you start with 7.21. But notice where the decimal is now at the 7, I would actually go this way to move it back to get it where it needs to be. And our resulting number, 0.00721, is clearly smaller than 7.21. So that means we are going to the negative power, and we moved it 3 places. So we're good there. So in this one, the same idea, but we're starting here. We want to go to the negative, so I would rate it and go 1, 2, 3, 4, 5, 6, 7, and fill in with the zeros. And that's how I get my answer. Simplifying an expression, always work on the inside first. All right, leave the -2. We are not doing anything with that yet. We're not doing with anything with the x plus 3. We're going to do this bracket first. Inside the bracket, we got to do that parenthesis. So we get y minus 5x minus 5y. Again, I'm going to say that a lot of the mistakes that students make can be avoided if you just take the time to write everything out each step. So then, again, my -2, x plus 3. I still need to clean up what's inside of there. I have y minus 5y is -4y minus 5x. Now that I have everything cleaned up inside the bracket, I can go ahead and distribute this 3. So it becomes minus 12y minus 15x. Again, clean up. In other words, combine what can be combined. So that looks like that's going to give me -12y minus 14x. And then, of course, that last step is to distribute your -2. And that's where you get your 24y plus 28x, which is also the same as 28x plus 24y. That doesn't change. Moving along. The word evaluate. That means you're going to plug in your known values. When you do that, it's very important you use parentheses. The a is being squared. I'm going to replace the a with -3. Again, you must use parentheses. Notice I put the parentheses first. I can almost rewrite the whole thing with those parentheses and then plug in what's needed. So the a goes here, the b goes there, and the b goes there. And then you go back to your order of operations. So we can clean up this in groups. You can do this, do that multiplication, do that multiplication. You got to go through, do the power and the multiplication stuff first. All right, this is not 5. We can't do it to 5 times -3 because that -3 is squared. This actually becomes, so I'm going to put it over here, 5 times 9. Now, I'll do this in pieces. -3 times -2 is +6. And then 4 times -2 is 8. Notice I'm just doing little bits at a time. That's 45. -3 times +6. And you don't have to put that plus there. I just did it there to emphasize that -3 times -2 is +6. So that's -18 minus 8. So I have 45 minus 18 minus an additional 8. You can just do that right in your calculator. Plug in your 45 first, minus 18, minus 8, and you're going to get 19 as an answer. Okay, so again, the part of this first page is for you to kind of understand simplify versus evaluate versus solve. When you solve something for x, now you're working with an equation and you're going to get an answer of x equals. So let's take a look. We're going to solve this equation. When you solve your equation, don't forget you need to simplify both sides first. Don't start doing anything else until they're fully simplified. So what does that mean? Here I need to distribute minus 6, distribute minus x plus 6. Continue simplifying each side. 8 minus 6. This is just basic simplify. We're not moving anything yet. 8 minus 6, of course, is 2. So I get 2 minus 2x equals 24 plus 6 is 30 minus x. Once you cannot simplify any further, that's when you have to start thinking about moving terms that are the same to the other side of the equation however you want. You can pick, it doesn't really matter. I always start with x's. That's just something I get used to. So I'm going to take this and move it over there by adding 2x. You could pick the negative x and move it over here. Again, that part's not going to matter. That leaves me with 2 because negative 2x plus 2x cancels out. Positive 2x minus x is plus x. To get the x alone, of course, minus 30. So I am left with negative 28 equals x, and that is my answer. Okay, I'm going to have to erase this because I need the space for this next problem. But you can go back and see it. So let me erase this. All right, for this next problem, now we have an equation with a bunch of fractions in it. And there's only one thing you should do here when you start problems like this is concentrate on how can I remove the fractions from the equation. Because it's an equation, you can do whatever you want to one side of an equation, as long as you do the exact same thing to the other side. So what I'm thinking here is when I look at 7x, right, plus 1, if I were to multiply this whole thing by 20, wouldn't the 20s cancel away? You know what's pretty cool? If I multiply this by 20, the 2 will cancel away because 2 goes into 20 10 times. And if I multiply this by 20, the 5 goes into 20. So basically you're picking a number, the lowest common multiple, that'll cancel all those denominators out. And this is what it looks like. I'm going to multiply this whole side by 20. Okay, but be careful. When I do this side, I must distribute. So what some people do instead of doing it like that is actually put up a second set of parentheses and distribute the 20 across. All right, so either way, you have to distribute that 20 so it goes to each piece on that side. All right, notice how nice 2, 20 is 10. So what does that leave me with? 10. Don't forget your parentheses, x minus 4. 5 goes into 20 4 times. 4 times 1 is 4. And 20 cancels with 20. By doing that, you have a nice equation with no fractions anymore. We can just go ahead and solve that. Distribute your 10. Again, combine. I'm going to move the 2x over this time. I'm going to subtract 2x. All right, let me move it off to the side here. So that gives me 8x minus 44 equals 1. Yes, hold on a second. My own handwriting got the best of me. That is not a 2. That is clearly a 7. So that's not an 8. Sorry, my 2 looked like a... my 7 looked like a 2 for a second. So it's 3x minus 44 equals 1. Add 44. I get 3x equals 45, and there you get your x equals 15. Answer. Now, what happens when we're solving for a variable? So I'm going to highlight that variable. I'm going to just underline it. I need to get rid of everything else on that side of the equation but the f. So I got to do this in pieces. First thing I notice is, again, I have a fraction. Let's get rid of fractions. We can simply get rid of a fraction by taking this whole side and multiplying by 9. We saw that in the last problem, and we are allowed to do that with an equation as long as you do it to the other side as well. Nines went away. All right. Well, I'm almost there. Remember, f stays, everything else goes, but you have to do it in the right order. I can't get rid of the 5 that's multiplied by the f because I got this minus 160. So we know, oh yeah, we just have to add 160 to both sides. And you might say, how do I add 160 to a 9c? Well, you don't really. You just write it as 9c plus 160. It's a formula. It's going to, you're not going to be able to combine terms very easily. But again, our only goal is to get f by itself. We're almost there. My next step, divide out your 5. So f 9c plus 160 divided by 5, which could also be written as 9c over 5 plus, what's 160 divided by 5? You don't have to write it this way. So what would that be? That would be 332. But you may have seen it. Either of these would be acceptable as an answer. When you are solving a variable and there's multiple variables in the problem, you're really just rearranging the problem. That's it. All right, an absolute value. When you see an absolute value equation, you have to stop yourself and be like, okay, there are 2 different values that can be inside that absolute value that have the same answer. In other words, absolute value of -3 and absolute value of 3 both come out to 3. Because you're going to have these 2, you need to isolate the absolute value. Get it by itself before you do anything else. So, in order for this piece to equal 5, I can actually have, yes, 2x minus 8 equal to 5, and say, all right, add 8, 2x equals 13, so x equals 13 over 2. In other words, if I plug in 13 over 2, the 2's canceled. 13 minus 8 is 5. 5 equals 5. That part's easy. But here's the other thing. That 2x minus 8 could also equal -5. So I've got to work that out too. So that means if I plug in 2 times 3 halves, 2's canceled. 3 minus 8 is -5. Oh, but the absolute value becomes +5. So you have 2 answers for an absolute value equation. The only time you don't have 2 answers is if the absolute value equation is actually equal to 0. This is a mixture problem. Local coffee shop wants to obtain 30 pounds of mixture of coffee beans, costing $4.40. They have mixture A that costs this much per pound and mixture B that costs that much per pound. How much of each should be used? All right. The first key here is they want 30 pounds. So we're going to let X be the amount of mixture A and let Y be mixture B. So the first thing that's kind of obvious is we know X plus Y added together must be 30. All right, that's the amount. But we also have a cost. So what this is saying is mixture A costs $4.25 a pound. So 4.25 times however much mixture A you have. Mixture B is $4.50 times however much mixture A. You're going to get a final mixture that cost $4.40, and you're going to have 30 pounds of that. So I'm not going to go into solving this because you can kind of see on the answer key how it is solved. It's just a system of equations. You can use, I think on the answer key, we use substitution. We did not do many mixture problems in class, so it's very unlikely I would give you a mixture problem. I would say go back to our discussion posts. I think we did some upstream, downstream problems, and just take a look at what word problems we did in class. But I wouldn't pay too much attention to that one. All right, graphing an inequality. Of course, you solve an inequality very similar to an equation. I have 9x, you got to distribute. The difference, of course, with an inequality is at any point that you divide by a negative. We can subtract, that's fine. We can add, that's fine. Notice the inequality doesn't change. The only time you have to stop and think about it sorry, that was negative. The only time negative 16 and 6 is negative 10 is when you do this piece. Am I dividing by a negative or a positive? If you're dividing by a positive, inequality stays exactly in the same direction. If that 5 were negative, I'd have to turn it to x greater, but it's not. Graphing it. I always put zeros on my graph. There's my negative 2. If there's no equal to part, that means our value cannot be equal to negative 2. So you have to have an open circle. And I want the values that are smaller than negative 2. So I'm going to shade in this direction. We also use interval notation. Interval notation goes negative infinity to negative 2. And it's open at negative 2. We don't use the bracket showing we include negative 2. Let's take a look at number 11. All right. Solve each of them separately. I'm going to add 2 to both sides. Which gives me 10. Sorry about that. So x is less than 10 over 4. Keep in mind, 10 over 4 reduces to 5 halves because I can divide both by 2. Put the or in there. Subtract 1, so I get 3x greater than 3x greater than 1. I want all values that are less than 5 halves or greater than 1. So again, I put my 0, I have my 1, I have my 5 halves. They both get open circles. But I want values that are smaller than 5 halves. Now, because this is an or, that means as long as the part of the number line hits one equation or the other, you include it in your solution. If it were an and, you can only include those parts of the number line that satisfy both equations. But no, because I'm going this way, and this one I'm going that way. It ends up being all real numbers. So your solution is the entire number line, and x is all real numbers. absolute value inequality. So just like the equation, you kind of set it up first without the absolute value, exactly as it is. And then here's a little trick. This becomes an inequality with the word or it becomes an inequality with the word and. It all depends on this sign right here. So I'm going to read it. 1/5 x plus 3 is less than 11/5. So here's my little trick. Because less than sounds more like and, it's an and. Think about it. If the symbol were greater than, greater sounds more like or, and it's an or problem. I know it doesn't make sense. It's a silly little trick, but it works. So we group these together with an and. And then I have same thing, but I'm going to switch two things. I'm going to flip the inequality, and I'm going to make that negative. So here is the inequality that satisfies that absolute value. You got to solve everything. We can do this by multiplying by 5. So when you multiply 1/5 x, so you can kind of take this, multiply by 5, multiply by 5. You have to do everything by the 5, don't forget. So what does that leave me with? Oh, x minus 15, negative 4. And on this side, same idea, multiply everything by 5. That's going to give me x plus 15 is greater than negative 11. So basically, if we're looking at a number line, which you don't necessarily need to do, negative 26 is in this direction, negative 4 is over here because 0 is out here. I want values that are less than negative 4 and also greater than negative 26, so right in between them. And if you were doing interval notation, it would be negative 26 to negative 4. Notice there's no equal to sign. Okay. Here's a good equation, a word problem. Triangle has a perimeter of 69 meters. The length of the second side is twice the length of the first side. The third side is 5 meters longer than the first side. How long is each side? All right, draw your triangle. Any triangle. We know the perimeter equals 69. What does perimeter mean? Side 1 plus side 2 plus side 3 equals 69. The length of the second side is twice the length of the first. Well, you got to just declare these 1, 2, 3. It doesn't matter where they are. Don't worry about interpretation in the picture. All right, so if x is the first side, the second side is twice x, and the third side is 5 meters longer than the first side. So that's x plus 5. And substitute them in. X plus 2x plus x plus 5. All right, what's that give me? 1, 2, 3, 4x. Subtract 5. 4x equals 64, so x equals 16. Go back to your triangle though. That means side 1 is 16. Side 2 is 2 times 16. And side 3 is 16 plus 5. So that's 32 and 21. Don't forget your meters. All right, moving along. Here you have a compound inequality. when you have a compound inequality, you can work from the inside. Just you have now 3 parts to it. So whatever you do to that middle part, you got to also do to the end pieces as well. So in other words, when I add 1, I got to add 1 over here and add 1 over here. So that gives me negative 10. The 1's gone. Divide everything by 2. Gives me negative 5. And you're done. Graph and find the x and y intercept. So of course, this is, to find an x-intercept, y must equal 0. Keep in mind, y was 0, x is negative 5. That is a coordinate, and you must write it as a coordinate. Now, for your y-intercept, and I'll stress again, a lot of mistakes come from not writing out all your work. You must have x equal to 0. Sorry, negative 10. Forgot the negative. So x is 0 when you go to graph it. All you have to do is plug those points on now. Negative 5, 0, and 0, negative 10 thirds, and there's your equation. Moving along, the equation of line perpendicular and passing through the point 2, negative 5. To write any equation of a line, you need a slope, you also need a point. So we have a point. We got a point. It's negative 2, 5. We're good there. We actually have something. What we don't have is a slope, but we have information to find the slope. The line is perpendicular to this line. Okay, that means let me first find the slope of that line. Well, finding a slope's easy. Solve for y. Right? Because if you solve for y, divide everything by 8, your slope is automatically the coefficient of x. So, but that's the slope of this line. All right? So the slope of 7x plus 8y equals 12 is negative 7/8. That line is perpendicular. Well, what do you know about perpendicular lines? When they're drawn, their slopes are what we call opposite reciprocals, meaning the slope of this line, if the perpendicular line's negative, this one's going to be positive. And reciprocal, instead of 7 over 8, it's going to be 8. So it's going to be positive 8 over 7. All right? Now we're done with that line. We don't need that. We don't need any of that anymore. This is the information we need to get our equation. All right, we're going to use point slope form. You need to know point slope form. We have our point, negative 2, 5. So we do, first thing we need is the y value of that point. So it's y minus 5. The slope we know is 8 over 7. And then the x value of our point is negative 2. But what's minus negative 2 is plus 2. All right. we don't normally leave an equation in this form. We go ahead and multiply everything by 7. So this whole side gets multiplied by 7, and that gets multiplied by 7. Those 7s cancel. This leaves me with 7y minus 35 equals 8 times x plus 2. Now, you will be told on the test whether you want slope-intercept or standard form. We tend to do slope-intercept. Slope-intercept would look like this. Add the 35. That gives me 51 when you add 35 and divide by 7. So it's 8/7 x plus 51 over 7. That makes sense. We wanted 8/7. So that's your slope-intercept. Standard form would actually be easier. If I go back to this piece, standard form is when you have the x value first. So I'd move the 7y over, move the 16 over. All right, to get standard form, I would actually have to subtract 7y and subtract 16. So it would give me negative 51. And you'd rearrange it. So be careful on the test, on the exam, if you're asked for standard or slope intercept. And of course, this is your point slope form. Know your forms of your equations. Know all of them. All right. Let me erase this. You can go back and look. All right, graph 4x minus 2y equals negative 6. So you have to graph first what we call the boundary line. The boundary line is simply that, 4x minus 2y equals negative 6. This is your boundary line. When I graph it, because there is no equal to sign, it will be dotted. If it were less than or equal to, you'd have a solid boundary line. All right, so we've got to graph this equation. We can quickly find intercepts. You can set it equal. You can graph it any way you want. Let's do slope-intercept form. Slope-intercept form would look like this. Move the 4x over, divide everything by negative 2. It gives me 2x plus 3. I just divided everything by negative 2. After moving the 4x over. All right, so when I go to graph that, my y-intercept is at 0, negative 3. I mean 0, 3, sorry. And my slope is 2 over 1. So that means I'm going up 2 over 1 or down 2 over 1. Done. All right, graph the function. Okay, there are a lot of different ways we can graph our functions, but one of the ways we can simply do it is just by getting points, right? So what's going on with this particular function? Hopefully you recognize it's a parabola, because anything squared is a parabola. And it's a negative parabola, so somewhere it's going down. All right. Now, throughout this course, we graphed functions using points, meaning just creating a table of values, right? And we could try all different values, 0, plus or minus 1, plus or minus 2, whatever. We also looked at things like a vertex, which is negative b over 2a. To graph it by a vertex, you would put the x squared first. And you would recognize, oh, a is negative 1. Notice there's no x term, so b is 0 and c is 5. So negative b over 2a, which is your vertex, is negative 0 over 2 times negative 1, which is 0. Since we know the vertex is 0, it's always good to start there. So plug in 0. Well, 5 minus 0 is 5. All right. We probably want to put negative 1 and positive 1 to see what's going on here. Plug in negative 1. Negative 1 squared, 5 minus 1 is 4. 1 squared, 5 minus 1 is 4. So let's see what we have so far. 1, 2, 3, 4, 5. And then we have 1, 4. So you will very quickly start to see this equation and what it looks like. And then you can graph it. Okay. If g of x, find g of negative 4, you're just plugging in negative 4. So g of negative 4 equals 1/2 negative, use parentheses. And it's 11. Solve each system. To solve that first system, I would go through and get rid of the fractions first. Take a look. I have a 3 and a 6. Multiply everything by 6. Okay, so what's that going to give me? 2x plus 5y equals 12. This one, take a look. You're just going to multiply everything by 5. Just get rid of those annoying fractions. And that's going to give me 3x minus 5y equals negative 7. You can then solve it any way you want. I always like elimination, because if you try to do substitution with this problem, you're going to get a lot of fractions. And notice, if you line it up, you already have something being eliminated. So you don't have to do anything. So that gives you 5x. Your x is 1. That's only your x value. This is a coordinate. You need to find y. By taking that 1 and plugging it in anywhere, I'm going to plug it in right here. So it gives me, that's 2. I'm going to subtract the 2 from both sides. Looks like I get 5y equals 10, so y equals 2. You can also plug it in here and see you get 3. Subtract 3, you get negative 5y equals negative 10, y equals 2. You get y equals 2 for either one. So there's your answer. All right, for the next one, again, you can use substitution for this one if you want, only because you can very easily solve for x. If you want to use substitution, it would be, you got to replace x with that, with y plus 3. Sorry, just trying to go too fast here, apparently. Minus 3y equals 1. 2y minus 3y is negative y. Subtract 6. You get y equals 5, and then, of course, x is 5 plus 3. And you get 8, 5. You can also do elimination. Take a look. And here you get to choose. Notice if I simply multiply this top one by negative 2, right, I would get negative 2x, negative 2 times negative y. But don't forget, you can also multiply it 3 equals negative 6. I don't have to multiply this one by anything. I can keep it exactly as it is. Then my x's will cancel. And I get negative y equals negative 5, y equals 5. So either way, I get the same answer. Solve the system of linear inequalities. All right. So for this one, you have to graph. This one's a little different. You got to graph your boundary lines. All right, first boundary line is 3x plus y equals 8. So that's y equals negative 3x plus 8. So I got to go up to 8. That's my y-intercept. And then go, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay. I'm going to go down 3 over 1. Dotted, because there's no equal to sign there. There's my first equation. Then I got to graph the second one, which is x minus 2y equals 5. Negative 2y equals negative x plus 5. Divide everything by negative 2. It's actually 1/2 x minus 5 over 2. Gets a little trickier. Negative 5/2 is negative 2.5. So that's there. That's your 0, negative 5/2. And it's up 1 over 2, up 1 over 2. And it goes something up 1 over 2, up 1 over 2. So it looks something like that. You don't have to get it exact. This creates 4 regions. Do you see them? This is region 1, that's region 2, that's region 3, that's region 4. 4 regions. I'm going to get rid of those. You have to pick test points and determine which region is correct. So, I don't know. Let's first test a point in this region. Well, I'm going to pick the easiest point, 0, 0. You come back to the original inequality, right? If I test 0, 0, I get 0 plus 0. Is 0 plus 0 greater than 8? Nope, that region doesn't work. We can get rid of that region. Go around. Let's pick a point over here. I'm going to pick something that's obviously in this region. I don't know. Let's do like 3, 5. Looks like it would be in that region. Well, if I test 3, 5, all right, I get 3 times 3 is 9 plus 5. Hey, that one works. 3, 2 times 5 is 10. No, 3 minus 10 is not greater than negative. So that region doesn't work. Don't worry, you'll get there. If none of them work, you're making a calculation error somewhere. Let's pick a region. Let's pick a test point down here somewhere. I want to make sure it's definitely in the region. I'm going to pick 2, negative 8. I'm just randomly picking anything. All right, 3 times negative 2. Sorry, I said 2, negative 8. There you go, 2, negative 8. 3 times 2. 3 times 2, I'm sorry, is 6 minus 8 doesn't work. All right, so the only region, and I purposely did that, I haven't picked yet is out here somewhere. So let's just pick the 0.90. All right, it should work. Okay, 9 times 3 is 27 plus, yep, that's definitely bigger. 9 minus 0 is greater than 5, yep. So this is the region that works. That's the region that gets shaded. Okay. A couple of these are more review stuff for you to practice, but this is a basic for X. I don't think I need to really go over this one. All I do is distribute and then combine like terms. So notice there's no equation. We're not solving for X here. I end up with, when I put my X squares together, it looks like I end up with negative 2X squared. When I put my X's together, it looks like I end up with 3X minus 7. Done. You don't do anything else with that problem. Squaring a binomial. At this point, as you move on in mathematics, you really should get used to the shortcut for squaring a binomial, which is simply square the first term completely. Oh, what's 5x squared squared? It's going to be 25x to the 4th. Double multiplying them together. So multiplying them together gives me 15x squared, but I'm going to double that and square the last one. That's a quick way of squaring a binomial. If you don't want to do that, all you have to do is FOIL it out, and you will see if you FOIL it, you're going to get the same exact answer. As you progress in your math courses, you're going to want to be able to square binomials pretty quickly, though. So you square it, square the first and last terms, but the middle, you multiply them together and double it, because if you go through the FOIL method, you'll see that's exactly what you end up doing. You have 2 of those middle terms. Long division. Let's take a look. I have x minus 1 divided into double check first. Notice you must have every exponent. 4. I'm missing a 3. It goes 4, 2, 1, nothing. Oop, I've got to erase that now. You have to have every. Since we're missing the 3, we stick in a placeholder before you put the rest of the problem down. Okay, it won't work. When you are dividing, everything just has to be lined up perfectly. If you remember that, you're going to be able to divide it nicely. Watch. First term into first term. What do I multiply x by so that it becomes 2x to the 4th? So I'm starting out with an x. I need it to be 2x to the 4th. Okay, I need an x cubed, correct? So always put it over. Because it's an x cubed, it's going to go in this column. But an x cubed is not enough. I also need the 2. So I need a 2x cubed. Okay, this is what I mean by everything has to be perfectly lined up. X cubes can only go in that column. All right, multiply it out. 2x cubed times x. Oh, yeah. 2. That's going to give me 2x to the 4th. 2x cubed minus 1. Make that negative. Minus. And then don't forget, we are subtracting. So that's minus. That's 0. That's good. They cancel. It's x cubed minus a negative 2x cubed. So that becomes plus 2x cubed. Plus 0 is just 2x cubed. Bring down one more term. All right, do it again. first term into first term. Well, now I need a 2x squared. Well, that's got to go over top of the x squared term. Notice again, only x squares in that column. Multiply it out. That's going to give me 2x cubed minus 2x. Oops. Sorry about that. Don't forget you are subtracting. That cancels. Negative x squared minus a negative, that becomes a plus. So I have a plus 2 and a minus 1 is going to give me just x squared. Bring down the next term. First term into first term again. I just need to multiply this one by x. Gives me x squared minus 6x. Minus x. I don't know why I put 6 there. Sorry about that. X times x is x squared. X minus 1 is minus x. Again, we are subtracting. That becomes plus, and that's now going to give me 7x. The last term's a 3, so I just need a 7 minus 7. We're subtracting. Cancels, that becomes plus. That gives me 10. So here's my answer. Over this piece, x minus 1. That's how you do your long division. This one, there's no simple way to do it. You just have to multiply everything out. So that gives me 9x cubed plus 6x squared minus hold on. Sorry about that. Let me redo that. That gives me 9x squared plus 6x. Yeah, minus 15x. Then go to this one and distribute it. That becomes minus and combine it all together. I'm not going to go through that. Okay. Factoring completely. You have a basic trinomial here. Learn these shortcuts. That can only be broken down to x and x. I want two factors of negative 22. Whatever they are, they have to add up to negative 9. So I want two numbers such that they multiply together to give me negative 22, but they add up to negative 9. Well, it looks like a negative 11 and a positive 2, because negative 11 and positive 2 equal that, and then add up to that. Done. You can certainly do guess and check on this one as well. It gets a little harder, and you're going to have to erase because it's much harder to break up 6x squared. 6x squared could be x and 6x. It could be 2x and 3x. There's a lot of different combinations. You can certainly play around with all those combinations, and then 21 is just 3 and 7, or 21 and 1. So it gets a little tricky there as well. And you have to put all those combinations together, or you can do the AC method, which means multiply A and C together, which gives me negative 126. And I want two factors that multiply the negative 126 and add up to 5. You're going to have to play around with that for a little bit, and you start a little chart of values, right? Oh, okay, 126 and 1. Well, that's not going to work. How about 2 and 63? That's not going to work. And you grab your calculator and you start, okay. Sorry, let me make this a little bit neater for you. Okay, I want a negative 126. So again, I could have 1 times 126, where one of them's negative. No. 2 and 60. 2 goes in 12. 6 times 63. That's not going to work because you're not going to be able to get to a 5. Because this is negative, we're subtracting somehow, but that's not going to work. 3. Try 126 divided by 3. I get 3 and 42. That's not going to get me to 5. Let's try 4. 126 divided by 4. That doesn't even work. You can't do 126 divided by 4. You can't do 126 divided by 5. Do 126 divided by 6. 6 and 21. Okay, this is honestly the only way to do it when you have big numbers. 6 times 21 gets me 126, but that does not get me to 5. 7, that doesn't work. 8. No, that doesn't work. 9. 9 and 14. 9 and 14 work. Because the difference between 9 and 14 is 5. Now, one of them has to be negative. I want the 9 to be negative because that 5 is positive. So now that I know my numbers, it becomes 6x squared minus 9x plus 14x minus 21. And you can solve by grouping. Let's group them. I would take a 3x, and I get 2x minus 3 plus 7, 2x minus 3. You know you did it right when these two are the same. So you write that one down, and then whatever's left. And there's your answer. That's your AC method. Or again, you could do guess and check, where you just sit there and do different combinations until you get the right one. And how do you know it's right? Some of you may have had an algebra teacher in high school that called it a rainbow method. You check this and you check that. Remember, 2x times 7 is 14x. Negative 3 times 3x is negative 9x. This is why it's called the rainbow method. Does this equal our original middle term of 5x? Yes, it does. That's how we check to know it's correct. I'm going to stop the video right here. Let me finish C and D first, and then I'll do the video in 2 parts because it'll be too long if I don't. All right, factor this one. I don't have a GCF. There's no common factor I can take out. I have to do my grouping. It's 4 terms. The only way to factor 4 terms is through grouping. X squared, 2x plus 3 minus 4, right? Oh, 2x plus 3. My grouping worked. But you got to make sure you're factored completely. This is good. This is not. This can get factored further. Keep the 2x plus 3. This is x minus 2, x plus 2. Now we're done. You need to factor till you can factor no longer. Here, we don't have squares, but we have cubes. We learned how to factor cubes. This one you just kind of have to memorize. The first one is a binomial, and it's simply the cubed root of everything. 2a minus 3, right? Cubed root of 8, cubed root of a cubed, cubed root of 27. Now it's a little memorization thing. Take the first term, Square everything. Change the sign. If it's minus, that one becomes plus. Multiply them together. And square the last one. So you square it, flip it, multiply it, square it. That's what I say. Square the 2a, flip the sign, take 2a times 3, and square the last one. That's your answer. All right, I'm going to stop this video and do it in parts, and I'll do the rest in a second video.